Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the Electrical Engineering channel. In this lecture, I am going to demonstrate how to evaluate the linear combination of vectors in a matrix. This thing we have directly written over here, but how we achieved this relationship of the third vector based on the first and the second vectors. So this uh, method of achieving this linear combination of vectors is also elaborated now. Okay, so this is very simple but a systematic method to evaluate the linear combination of one vector based on the other two vectors. So how to determine linear combination? S is equal to 2, 1, 3, 5, 1, minus 15, 3, 1, 7. First, we have to evaluate the transpose of this matrix. So S dash will be equal to 2, 1, 3 will be the first column, 5, 1, 15 will be the second column, and 3, 1, 7 will be the third column. So let's make this entry equal to 0. So we have to perform R1 minus 2 R2. This is written over here. And the new second row will be 0, 3, 1. Now let's make this entry equal to 0. So we have to perform 3R1 minus 2R3. And finally we will get 0 minus 15 minus 5 as the third row. And this is our first operation R1 minus 2R2. This is our second operation 3R1 minus 2R3. And by looking at the second and the third rows, the third row is equal to minus 5 times the second row, right? And the third row is actually 3R1 minus 2R3. And the second row is R1 minus 2R2. And third row is equal to minus 5 times the second row. So 3R1 minus 2R3 will be equal to minus 5 times R1 minus 2R2. Let's solve this equation, and after doing some rearrangements and cancellations, finally we will get R3 equal to 4R1 minus 5R2. So these are actually the rows, but initially we took the transpose of the S matrix. Okay, so that's why we have achieved this relationship between the rows. But if we take the transpose of this matrix back, then these rows will be equal to the columns. So C3 will be equal to 4C1 minus 5C2, or we can say V3 is equal to 4V1 minus 5V2. And that is what we actually wrote here directly. V3 is equal to 4V1 minus 5V2. But at that time, we didn't know how to evaluate this linear combination. So this is actually the method in which we can evaluate the linear combination of the matrix. So that is all about our today's lecture, and I hope you have understood the concept of evaluating the linear combination. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.